Hello, today I have two things to talk about. The first one being embeddings at scale, and the second one is semantic pattern search. My roommate Mark is in mechanical engineering, and over his past work, he told me about the problems with searching for patents. Patents usually involve a lot of sciencey terms, and when you're querying it on something like Google, which uses syntactic search, it's not really easy to look for the exact patents you're searching for. But that's the exact problem that semantic search solves. The demo I'm going to show you is crawling through patents on Google, scraping data from them, embedding those, quantizing those embeddings, because we're talking about embeddings at scale. And then finally, we get the application layer where we search for them and we get the exact patents that match our criteria. So let's dive right into the demo. And our demo. So I'm going to run search.py and I have these topics. So I'm going to first search wind turbine. That's going to load up the embeddings and then run the semantic search. Gives us something in line with wind energy. Then automobile braking. This also gives us similar braking stuff. And then there's something that's wrong here. But that's just because we have not indexed enough patents. Now let's actually look at our code. So first I have a crawler.py. It goes through this website and collects all the different URLs that Google has on its patent subdomain. Now we're going to take that and then filter through it. We're going to scrape it. And a usual patent page looks like this, where it has a title and it has an abstract. So I actually embed this abstract, and I'll talk about the embedding later. And then I store this title to show later on in the search. And then I have a few helper functions. So embed.py is where embedding and quantization happens. So for embedding, I basically use this mini-LM language model-based embedding. It's a small embedding model, so it's fast. Then I quantize it, run a very simple quantization algorithm, normalize it, clip it, scale it, and then quantize it to int8. Everything stored as NP or NumPy, and that is because I built a small, simple vector database using NumPy, where I can add the vector and then search for similar embeddings, and that uses cosine similarity. All of this is super fast for two reasons. Firstly, my model is very small, and secondly, my embeddings are int8, not float32. So int8 embeddings are faster and get stored in lesser space. A few more things that you can do to make this even better: use a smaller embedding model and then also fine-tune it for your search purpose. Really quick note on the power of semantic search. This is an example that Mark told me about from his previous work. They searched for crispy crunch manufacturing patent US. Not exactly that, but along those lines. That gives me these results on Google's patent search application. And if I go on metaphor search, shout out Metaphor Systems, and I search the same thing, the first link is exactly what they were looking for their research. Thank you so much for watching. If you need help implementing any of this within your organization, please feel free to reach out, and I'll try and help you to the best of my abilities. Thank you.